Consider the hypothesis test. Null hypothesis, P1 minus P2 less than or equal to 0, versus alternative hypothesis, P1 minus P2 greater than 0. The following results are for independent samples taken from the two populations. In the first sample, the sample size n1 is 200, and the sample proportion P1 bar is 0.22. In the second sample, the sample size n2 is 300, and the sample proportion P2 bar is 0.16. Part A, what is the p-value? So the first step is to calculate the pooled estimator of p bar, and plugging in the numbers into the formula, we obtain 0.184. The next step is to calculate the z test statistic, and again we just plug in all those sample values into our formula and obtain the value 1.7 for the test statistic. And we're using a standard normal distribution to find the p-value, and since this is an upper tail test, that will be the upper tail area to the right of 1.70, and so we look up in the standard normal table the area to the left of 1.70 and then subtract from 1, and so we obtain 1 minus 0.9554, which comes to 0.0446. And finally part B, with alpha equal 0.05, which is our hypothesis testing conclusion. So since the p-value is less than 0.05, we're going to reject the null in favor of the alternative, so there is evidence that P1 minus P2 is greater than 0.